Okay, let's take a look at number 9 here. This question involves enrollment. Okay, this will be an example of testing the difference between two proportions. It says in a survey of 200 males ages 18 to 24, 39% were enrolled in college. In a survey of 220 females ages 18 through 24, 45% were enrolled in college. At alpha equal 0.05, can you support the claim that the proportion of males who enrolled in college is less than the proportion of females who enrolled in college? Okay, so what I want to do is I want to write the null and the alternative in terms of the two parameters p sub 1 and p sub 2. Okay, so the question is, can we support the claim that the proportion of males is less than the proportion of females? Okay, so this is p sub 1 less than p sub 2. Okay, so this will be males and this will be females. Okay, so because this does not contain the case of equality, this is the alternative. Okay, and this happens to be the claim. So this makes the null hypothesis P1 greater than or equal to P sub 2. Okay, now before we go in and start calculating the test statistic, I do need to mention that in some of the homework problems you're going to be asked to check the assumption to use the z-test. Now remember from chapter 7, to use the z-test for proportion, we had to show that n times p and n times q were both at least 5. Here we need to show that n times the pooled proportion and n sub 1 times the pooled proportion and n sub 2 times the pooled proportion, and then also do that product for both for the failure. All four of those are at least 5. Okay, so what we need to check is n sub 1 times the pooled proportion is at least 5. N sub 2 times the pooled proportion is at least 5. N sub 1 times the complement to that pooled proportion is at least 5. And the same thing for the second sample. Now I do ask for this on your lab, so make sure you include that part. So we're going to need to find the pooled proportion. It's really easy to do. We just have to combine the successes and combine the sample sizes. Okay, so in this problem, we're told that, let me get back to that page, we're told that 39% were enrolled in college for the 200 males. Okay, so x sub 1 would be equal to 0.39 times 200. Okay, so let me do that real quick. Okay, that was 78. And x sub 2 was for females, okay, and it said that 45% out of 220 were enrolled in college for the females, so that's going to be 0.45 times 220. Okay, so real quick, that's equal to 99. Okay, so to calculate the pooled proportion, I'm going to add 78 plus 99 over 200 plus 220. Okay? Okay, doing that in the calculator, I'm going to use parentheses so I won't get my answer to be something crazy. Okay, I get the pooled proportion to be about 0.42%. Okay, it's carried out a little bit further, but let's just go ahead and round to 0.42. So that necessarily makes Q bar 1 minus P bar, the pooled proportion here, so it'd be 1 minus 0.42. Okay, so 1 minus 0.42, I should be able to do that in my head. Okay, okay, we get 0.58. Okay, so going back to checking the assumptions, I'm going to just real quickly check all 4 of these. Okay, so N1, my sample size was 200, so 200 times 0.42. I need to check if that's at least 5. 220 times 0.42, is that at least 5? 200 times 0.58, is that at least 5? And last but not least, 200 times 220. Now I'm getting myself all mixed up. Okay, if you go too fast, you make mistakes. All right, there we go. Okay, so basically I'm saying, is 42% of 200 at least 5? Okay, so this is going to check out for all of the problems. So that checks. This will certainly check. In your lab, I asked for these values. Okay, so please don't forget that part. Okay, and last but not least, I get 127.6. Okay, so the assumptions were meant to use the two-proportion z-test. Okay, not all of your homework problems will ask for this step, but the ones that do, I want you to be sure that you can find the pooled proportion, plus again, you have to do this in your lab. Okay, now the standardized test statistic for this thing is a little complicated, a little clunky to input into the calculator by hand. Okay, so let's go ahead and do that, and then we'll go back and just get it directly from the two-proportion z-test. Okay, I don't need you guys to do these by hand. Okay, if you have a built-in two-proportion z-test on your calculator and also in StatCrunch, I encourage you to go ahead and use that. Okay, but let's go over the pieces. Okay, so here's the standardized test statistic. Okay, it's not very pleasant. Okay. It's on page 448. Okay, it's going to involve the pooled proportion. Okay, so it's our observed difference, that p hat sub 1 minus p hat sub 2. Okay, and p hat sub 1 was the sample proportion for males. Okay, so in that problem that was 0.39. And then I need to subtract the sample proportion for females. Okay, so in the problem that was given to be 0.45. Okay, now let's take a quick look at the other part of the numerator. Okay, so we just put in this part, p hat sub 1 minus p hat sub 2. But let's talk about this one. Okay, we are subtracting the claimed difference between the two. Okay, now for us, in an Intro to Stats class, this is always going to be 0. Okay, and the reason why is if we go back to our hypotheses, if I were to subtract P2 from both sides of this inequality, this side would be 0. Okay, so in other words, this is the same thing as saying P sub 1 minus P sub 2 is less than 0. Okay, so this difference is less than 0. That's what we're going to put in for that P1 minus P2 part in the numerator. Okay, now the denominator is a little cumbersome. Okay, it involves the pooled proportion and then the complement to it, so it's going to be under the radical. We have 0.42 times 0.58 times, let me extend that radical, 1 over the first sample size, which was 200, plus 1 over the second sample size, which was 220. Okay, so you need to be real careful entering this into your calculator. So again, I'm going to strongly suggest just getting the test statistic directly from the two-proportion z-test. Okay, but I'll go over the steps. Hopefully I'll be able to get this. Okay, this can be sometimes tricky for me. Okay, so in this numerator I have 0.39 minus 0.45. Notice I put parentheses around it so that the calculator knows to divide this entire difference by the denominator, not just the 0.45. Okay, then divided by, I'm going to open up that radical. It's going to be 0.42 times 0.58 times 1 divided by 200 plus 1 divided by 220. And then close that parentheses and then right arrow out. Okay, so hopefully this will be the correct standardized test statistic. We'll verify that when we use the two-proportion z-test. Okay, so I get a test statistic of approximately 1.244. Now, even if I did put this in the calculator correctly, we may be off a little bit from what we find using StatCrunch and also the two-proportion z-test, because we did some rounding here with the pooled proportion and its complement. Okay, so I would not be surprised if this were off just by a smidge. Okay, so whenever possible, try to carry these two out as far as you can. And I know that's really cumbersome, so if you just feel more comfortable getting the standardized test statistic directly from technology, I'm fine with that. Okay, so let's go ahead and find the critical value. Now this is a z-test, so I'm looking for a z-score. So I'm going to draw a standard normal curve, put 0 in the middle, and looking back at the alternative, okay, this is a lower tail test, so I only need to shade one area of rejection. And let's, I forgot what the level of significance was. At 0.05. Okay, so we're using 0.05 for a level of significance. Okay, so at this point, this should be not any big deal to find a critical value from a standard normal table. Again, this is section 5.3. You can use your inverse normal, okay, which asks for a cumulative area, and the output will be a corresponding z-score. Okay, so I'm going to go to my distribution menu, select inverse norm, and put in that area. Okay. Okay, so that lower critical value is negative 1.645. Okay, so let's take a look at where our test statistic lies. Okay, our test statistic for this problem is negative 1.244. Okay, so looking at where it's placed on this horizontal axis, it's to the left of this negative critical value. Okay, it's in here. Okay, so in other words, it's in the fail to reject region. Okay, so the decision is to fail to reject the null. Okay, so we are in favor of the null. Okay, so that means that there is insufficient evidence to support the claim that the enrollment rate for males is less than that of females. Okay, so it's possible that a type 2 error may have occurred. Okay, so real quick, let's go back and get the test statistic, and let's go ahead and get the p-value, okay, from the calculator. Okay, because there is a built-in two-proportion z-test. So I'm going to press on stat, right arrow over to tests, and I want to scroll down to the two-proportion z-test. Okay, so x sub 1 is 78. Okay, I was playing with this earlier on my calculator, so it just saved that value. My first sample size was 200 males. Okay, number of females that were enrolled in college was 99. That would be the number of successes for females out of 220. Okay, so now I can go ahead and change my direction of the alternative. This was a lower tail test. And then press calculate. Okay, so the calculator gives a test statistic of about negative 1.2436. Okay, so comparing that to what we got by hand, that's actually pretty close, even though there was some rounding going on here. Okay? Okay, so again, getting it directly from the calculator saves a lot of calculation time. Okay, so from the TI 84 to proportion z-test, the standardized test statistic was negative 1.2437. Okay, so that does round to what we got by hand. Okay, but what's nice is we get the corresponding p-value. Okay, so the p-value for this problem was 0.107. Okay, rounding to 3 decimal places. Okay, you need to round to however you're told to round in my stat lab. Okay, so again, this is consistent with failing to reject the null. Okay, so comparing our p-value to our level of significance of 0.05, the p-value is greater than 0.05. Okay, so the decision is to fail to reject the null. Now we need to restate the claim or address the question. Okay, the question is, can you support the claim that the proportion of males who enrolled in college is less than the proportion of females? Okay, so I'm going to say there is insufficient. Okay, I could be neater, right? I could be typing this. There is insufficient evidence to support the claim that the proportion of males enrolled in college is less than that of females. Whew, my hand is sore. Okay, so because we failed to reject the null, again, it's possible that a type 2 error may have occurred. It does not mean that it absolutely did. Okay, remember, if we reject the null, a type 1 error may have occurred. If we fail to reject the null, a type 2 error may have occurred. One thing I want to point out from the calculator output is that it calculates that pooled proportion for us. Okay, so remember at the beginning of the problem, to check the assumption, I had to go ahead and find that pooled proportion. Okay, there it is. Okay, so I guess a roundabout way is to temporarily assume we could use the 2 proportion z-test, put the information in, find this pooled proportion, check the assumptions, and then go back to the screen and pull out the pieces we need. Okay, last but not least, let's take a look at the confidence interval. Okay, since the level of significance was 0.05, we want a 95% CI for P1 minus P2. Okay, the difference between the 2 proportions. Okay, so the calculator should have a two sample proportion interval. Let me find it. Here it is. 2 proportion Z interval. Now again, I don't ask for this on your lab, but I like to incorporate a confidence interval to help reaffirm what we're seeing in the decision to either reject or fail to reject the null. Okay, so once I select 2 proportion Z interval, what's nice is that it carries everything over from my hypothesis test. I don't need to change this level of significance, but I could. I'm sorry, this level of confidence, but I could. Okay, so the confidence interval limits go from about negative 0.15 up to about 0.03. Okay, I could carry that out a little further if I wanted to. Okay, so look at these confidence interval limits. Okay, this confidence interval contains 0. Okay, the case of equality. Case of equality from the null. If this confidence interval did not contain 0, in other words, if it was completely above zero or completely below zero, then that would be consistent with rejecting the null. But that's not what's happening in this problem. Because this confidence interval contains the case of equality, the case of no difference between the two, then we are ruling in favor of failing to reject the null, and in this particular problem, not supporting the claim.